Today we'll be demonstrating the use of a CO2 laser to make the wheel portion of our Geneva Wheel assembly. A CO2 laser is a device that runs electricity through a gas-filled tube to produce light, which lies in the infrared portion of the light spectrum. This light is run through a series of mirrors and lenses and is used to either cut or engrave material. CO2 lasers come in many sizes. The one we are using in this video is a small universal brand laser that runs at about 50 watts maximum. This is powerful enough for engraving and cutting many non-metallic materials, such as certain plastics, wood, etc. For safety, we will be wearing safety glasses as well as being careful not to stare directly into the laser. We will need to use a built-in ventilation system in order to remove fumes and smoke from building up in the laser. Only certain materials should be cut in the laser. Many plastics either do not cut well or can release harmful gases when burned by the laser. Only approved materials should be used. For our Geneva wheel, we're going to use a common plastic used for laser cutting called acrylic. If we open the laser's lid, we see the cutting table. This is where our material sits. The table will need to be checked to make sure that the Z-axis height is calibrated correctly. If the Z-axis height is not calibrated correctly, the laser will not be focused properly on our material and will make for poor laser engraving or cutting. We calibrate the Z-axis height with the calibration block given to us by the manufacturer. This block is used to position the laser's lens 2 inches above the cutting table in order to calibrate the machine. As you can see, our machine is calibrated just right. We remove the protective coating from our acrylic sheet and insert it into the cutting table. We make sure to seat the material so that it lies flat on the table and is registered in the top left corner of the table. In this example, we use AutoCAD to process the data that will be sent to our laser. You can see here that we have 21 parts nested into one sheet of acrylic. Each part takes about 5 minutes to complete, so the entire sheet will take more than 1 full hour. In our software, we have 3 main line types to deal with when using the laser. First, we have cut lines, which are put in the red AutoCAD layer. These lines are set to be laser cut all the way through the material. Second, we have vector mark lines, which are placed in the blue AutoCAD layer. These lines are used to engrave the workpiece by following a vector line path. These are used to mark along a single line from beginning to end. Last, we have raster mark lines, which are placed in the white AutoCAD layer, but will show as black in the laser software that we will talk about shortly. These lines are used to engrave a filled portion instead of following a line. The laser will move back and forth in the X direction while slowly stepping down in the Y direction, much like an inkjet printer, to make these engravings. For our Geneva wheel, we will only be using the cut and raster mark lines. We will not be using any vector mark lines. We use the plot function in AutoCAD to send the data to the laser program. This uses a driver that is very similar to a standard ink printer driver. Now our data automatically opens in the universal brand laser software. We will need to adjust the settings for our particular type and thickness of material. First, we choose the type of material, which is continuous cast acrylic. Then we set the material thickness. We will need to measure our acrylic because the acrylic often comes a bit thinner than the nominal size at which it is listed, and could vary by batch or manufacturer. Here we see that our acrylic measures at 0.22 inches or 220 thousandths. We will enter that into the software here. Now we will check the power settings. The settings are automatically adjusted by the laser software for the type of material and the thickness, but the settings may need to be adjusted to account for slight differences in materials or actual power output from an older CO2 laser. For our Geneva wheel, we are only worried about the cut lines, which are red, and the raster markings, which are shown in black in the universal brand laser software. For the raster marks, we see that a high speed and low power setting is used. The speed and power suitable will depend on the machine and the type of material being used. For the cut lines, we see that a low speed coupled with a high power setting is used. Again, the speed and power suitable will depend on the machine and the type of material that is being used. If the settings are deemed suitable, the laser can be started after ensuring that the ventilation system is on. Now we will watch as the laser first raster engraves and then cuts our part from the sheet. We have sped up this portion of the video at 500%. Normally, this process would take a total of around 5 minutes. And there we have it, our completed acrylic Geneva wheel.